to see what my version of one possible answer set might be for this writing assignment. We're thinking about limiting reactants and mixing a certain amount of magnesium metal with hydrochloric acid. We're imagining, I think one of the, well, rewind. I'm imagining one of the most helpful tools in limiting reactant questions. Simply think about maybe number of moles of this and number of moles of that. From the balanced equation that you probably just Googled, or not, two hydrochloric acid particles, units, react with one magnesium metal atom to give 1 unit of magnesium chloride and 1 molecule of hydrogen gas. But if I dare think about 100 millimoles of magnesium and 100 millimoles of HCl, I ask myself which one's limiting. Since there's a 2 in front of the HCl, that means this mole quantity should be 2 times more than this mole quantity. So if I had 100 millimoles of magnesium, I would rather have 200 millimoles of HCl, but I don't have it. Because I don't have it, I'm going to call HCl limiting, and it'll go all the way down to 0. The magnesium will go down, but it won't go down by 100, it'll just go down by 50 because this number is only half of this number. Likewise, I'll produce 50 millimoles. There's a 1 here, there's a 1 here, this is 50, and I'll also create 50 millimoles of hydrogen gas. 0 plus 50 is 50, 0 plus 50 is 50, 100 minus 50 is 50, 100 minus 100 is 0. So then thinking about what that would look like over time, once I reach completion, all the HCl will be used up, half the magnesium will be used up, half of 100 is 50, so I went down to 50 and flatlined my magnesium amount after completion, and the H2 gas will be nothing in the beginning but go up to 50 millimoles. That's a thinker, but it's a good one. It's a good one to think about, good one to ask questions about. Our textbook, and I usually don't teach stoichiometry using tables like this, but I've seen some books do it, and I think it is useful, especially when thinking about limiting reactant questions. Although in Gen Chem 2, soon you'll learn that it's not, just doesn't go down linearly. So over time, as the seconds tick by, as I go from the beginning to the end of the reaction, it's not a linear progression usually. Many times it's curvy, and so I drew some curviness in there to say, well, what if it's not a straight line linear decrease or increase to the constant ending amounts? So I don't know, what cartoon did you draw for the limiting reactant cartoon question? I just chose whatever. I chose aluminum reacts with oxygen to give aluminum oxide. Thinking about 4 aluminum atoms reacting with 3 oxygen molecules. I'm drawing a big old fat equation for that. 4 aluminums for every 3 oxygen molecules. So 1, 2, 3, 4 aluminums for 1, 2, 3 oxygen molecules. And then just making up some random quantities. Like what if I had 32 aluminum atoms? That's totally random. And 25 oxygen molecules? That's totally random. In other words, that would be 50 oxygen atoms, but I really don't care about that. All I really care about is the 4:3 stoichiometry ratio that came from my original balanced equation. So if I just randomly, like I said, came up with 32 aluminum atoms, I might ask the question, how many oxygen molecules would that be? So since it's a 3:4 ratio, 4 aluminums for every 3 oxygens, 32 times 3 divided by 4 is 24 oxygen molecules. And lo and behold, I do have 24. I have a little bit more than that. So I have excess oxygen. Or you can word it the other way, saying if I had 25 oxygen molecules, it's a 4:3 ratio for the aluminum atoms. And so 25 times 4 divided by 3 is 33-ish. Why did I put a question mark there? I don't know, it's wrong. By that, no, I mean 33 is more than 32, so, oh yeah, so for 25 molecules of oxygen, I would rather have 33 aluminum atoms, and I don't have that. I have less than that, so I'll call aluminum limiting, oxygen excess. If I knew oxygen was excess, I could already say aluminum is limiting, or if I knew aluminum was limiting, then I could say oxygen was excess, so I wouldn't have to do both of those. But then I drew one more picture, and here it is. So, oh yeah, so 1, 2, 3, 4 reacts with 1, 2, 3, and 1, 2, 3, 4 aluminums react with 1, 2, 3, and 1, 2, 3, 4 react with 1, 2, 3, and yada yada yada. And there's some of the structure. So, yeah, 1, 2, 3, 4, 1, 2, 3, and all fits together, and I've got one leftover oxygen molecule. Isn't that cute? Just kidding. But I really enjoy your limiting reactant cartoons, and I appreciate your watching this, of course, and more importantly, submitting your writing assignment on time. See you in class, guys. Thanks.